Hello, my name is Ömer Fatih. In this video, I will present my graduation project. In this project, I designed a one-dimensional photonic crystal. Photonic crystals are the structures that affect photons, like semiconductors affect electrons. Their photonic bandgap, which prevents electromagnetic waves to propagate in a specific range, allows us to use them in certain applications. For example, optical communications, laser applications, several different sensor applications, healthcare, and many more. In the design of the photonic crystals, there are many ways. One of them is to implement a mathematical series to the design. The most popular series are Fibonacci series, Thumor sequence, Cantor set, etc. In this project, look-and-see sequence is implemented in the design. For the first time, the results of the simulations show us that look-and-see sequence is a good alternative to the popular series. In order to simulate the designed photonic crystal, the algorithms are developed in MATLAB and transfer matrix method is used. There are two different materials used in this project, and their transfer matrices are calculated firstly. The material order of the designed structure is shown here. A and B are the materials used in this layer, used in this project. The transfer matrices of the A and B are calculated with this formula. And after the calculations of these layer materials, layer matrices, we put them in order so that we can obtain the whole transfer matrix. With this transfer matrix, we can calculate the transmission coefficient. And with this transmission coefficient, we can calculate the total transmittance. And total transmittance gives us, if you plot the total transmittance, this gives us the transmittance characteristics of the structure. As we can see from these graphs, by increasing the repeat number n, we can obtain more transmittance peaks. And if we analyze it more detail, in more detail, we can see that these transmittance peaks are increasing linearly. By linearly, I mean around 600 nanometers, the number of transmittance peaks changes with 2n-1 formula. And around 400 nanometers, the number of transmittance peaks changes with n-1 formula. These characteristics are very useful. This controllable transmittance peak characteristics is very useful because the user can adjust the number of transmittance peaks according to their studies, and they can be used as channel multiplexer, optical channel communication component, optical communication channels, fiber optical communication channels, and so on. This was all I wanted to say. Thanks for watching my video.